Creating Other Schema Objects Part 1 of 2. This is the first of a two-part mini-series in which we examine some of the other schema objects in Oracle Database 11g. Specifically, we're going to look in this nugget at sequences which perform a really nice function for database developers who need to generate, well, a sequence of unique integers, primarily for key constraint columns. And then number 2, we'll look at views, which are referred to as virtual tables. This can be sometimes a confusing subject to those who are new to database administration and database development, so pay particular attention if you fall in this camp, and I'm convinced that by the end of this nugget you'll be on very solid ground indeed. Let's get to work. At this point, if you've been following our training sequentially, you know how to create tables, you understand what data types are, and you also know how to apply constraints. That having been said, we know that it's crucial in a relational database schema to have one or more columns that define the uniqueness, the row-level uniqueness in a table. And we know that the primary key and foreign key constraints are specifically used for that purpose. We can also use the unique constraint as well. However, to ease data entry and to reduce the possibility of human error, yes, that's a common theme in database design, isn't it? Oracle gives us this object called the sequence. Formally defined, a sequence is a schema object, that is to say it exists in the data dictionary permanently, that's used to auto-generate integers. Integers are whole numbers, 1, 2, 3, maybe we could do 100, 200, 300, etc. And the purpose of this is to, in most cases, we use sequences to generate surrogate keys for the number data type. Obviously, we'd want to use number for an integer. Formally defined yet, a surrogate key in a database, this is according to Wikipedia, is a unique identifier for either an entity in the modeled world or an object in the database. And we know again, primary key, foreign key are our main surrogate key types in Oracle 11g. If you've used desktop database applications like Microsoft Access, Access has a data type called AutoNumber that functions the same way. It enables you to just boom, 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 kind of automate the generation of these unique integers. Of course, we can't have a collision, that is to say two rows with the same key value, so sequences can be useful, but there are some caveats or concerns to be had here with Oracle. Oracle sometimes makes things that should be simple more complex than they need to be, quite honestly. Sequences, because they're schema objects, they're reusable. That is to say, we can build a sequence, let's say, that starts at ID 1 and then increments 1 at a time, ad infinitum to infinity. And we can apply that sequence to a primary key-bound column in table 1, let's say, and our data entry clerk just is merrily cooking along. We can reuse that sequence for another table. Let's say we bind it to a key column in table 2, and when we pull out the next number, are we going to start at 1 or are we going to start at 7? Well, we're going to start at 7 because a single sequence is never going to repeat a previously dispensed value, you see? So that's the caveat. You'll generally speaking want to use a sequence per table. They're reusable but only to a degree. Another thing we can do with sequences that's nice performance-wise is cache n number of values. That is to say, we can create a sequence again that starts with 1 and increments by 1, and we can set cache to like 10, and that keeps the next 10 values stored in memory. This can be handy for volatile tables that are generating a lot of new rows. If Oracle has the next number in the sequence in memory, it stands to reason that it should be easier and faster to put that sequence in during data entry. Now, the caveat or warning with that is, if the system goes down unexpectedly, let's say there's a power outage or a system freeze, whatever, you lose the numbers that have been cached. So let's say we're on sequence number 7 and we're caching the next 10 values. So we've got 10 through 17 in memory all ready to go, and then the server locks up and we have to force a restart. We come back from that restart, we do our next data entry insert into the table, and guess what? 18 is going to be the next usable value in that sequence. 10 through 17 that existed in memory, as you know, memory is volatile. They go up the flue. Now, of course, because sequences are schema objects, we can always use alter sequence to reset the counter to a specific value, but that's just something, again, that I want to make you aware of. Now, you may be wondering, when you're doing inserts, when you're doing your data entry, entry to add new rows to a table that uses sequences, do you just do nothing? In other words, is any effort required on the part of the data entry operator? Well, yes and no. Sequences need to be pushed to generate a new integer, and what you have there is what's called a method. In object-oriented programming, a method is an action that's performed by an object. It's a capability that's built into a specific object. And the way you call methods is you specify the object name, in this case the sequence, a dot or period, and then the name of the method. And the method that you need to know in this context is called nextVal, one word, Nextval. So that in your insert you would just specify the sequence name dot nextval, and Oracle will generate the next available number and put it where you want it to be. So that in a nutshell is how sequences work. Let's examine the syntax next. It's pretty straightforward. Like any other schema object, we have our standard data definition language, DDL statements. To create a sequence, we use create sequence and then give the sequence a unique name. I would advise using, for instance, SEQ either as the prefix or suffix of your sequence so that it's very clear to you and your colleagues what's what. As far as clauses to customize the sequence, these are the basic options here. We have start with, and then you specify an integer. It could be 1, it could be 100, it could be 1,000, it's whatever you want. Increment by, and then you can specify your increment value. It doesn't have to be 1. You can increment by 3, 5, 10, 100, whatever it is that your business needs dictate. You can also specify min values and max values. By default, no max value means you're just going to keep going ad infinitum, but there may be a case where you need to cap a sequence at a particular high value. Just specify max value space and then the integer that represents that. The sequence isn't going to work once it reaches the highest value. And we have the cache option. No cache means that Oracle is not going to cache any future sequence integers. Alternatively, we could specify cache space and then an integer to instruct Oracle to cache the next n number of sequence values for easy production. Again, basic DDL. If we have changes to make, if we want to change the increment value, or maybe we had a max value and we want to remove it, maybe we weren't caching and we want to turn it on, or maybe we had caching turned on and we want to turn it off, we can just specify alter sequence and then use these same clauses. We can rename sequences, but again, same rules apply with renaming sequences as renaming tables. If you have dependencies, you might find that stuff breaks in the database. So we want to be really careful. Know that the rename capability exists, but also be really careful that you're not breaking other code in your database system. And of course, drop sequence will make that go away permanently without any confirmation either. Let's now move away from sequences. I think we've covered that adequately, and I'll show you some techniques for leveraging sequences in our upcoming demo, and instead take a look at views, a sometimes confusing topic. A view is nothing more than a stored SQL query, essentially a select statement that's going to gather X number of columns, X number of rows from one or more base tables. This is a term that you should be well aware of. The base tables represent the actual honest-to-goodness tables that comprise the fundamental data store of your Oracle database. We use views to aggregate data from one or more tables. When we construct a view, we are in fact using a select statement, so we can use all of the join syntax that we learned earlier in the course to make use of the view. Thus, I think you can immediately see the business benefit of views. You can store a really potentially complex query that aggregates data, combines data, allows your folks to do some heavy data analysis without having to know anything about writing SQL, number one, and number two, they can stay far away from those base tables. Some common uses of views are to, as I just said, to hide data complexity, not just in terms of wonky table names and column names. You absolutely, when you create views, can alias those columns to make them easier for your users to understand. But as I said, you can pick and choose which columns you want to show, and you can hide columns that are sensitive, columns that your users have no business seeing. Maybe there's something that database administrators and developers should see, but not something that your customers or database users should see. We can protect those base tables. Remember that we have the notion of the constraint, and that we can build those constraints at the table level. We can also add constraints on views. So we have the view riding herd on the table. We have constraints on the table. We have constraints on the view. We're putting a good deal of protection on our database at this point. Of course, there's always that seesaw or that counterbalance effect between high security on one hand and performance on the other. You want to be careful with your constraints and not overburden your objects. And then finally, we can present data differently. I've already mentioned that though. Another advantage of views that isn't on my little punch list that I'll add now is consistency. One principle of application development. We haven't talked about development much for two reasons. One, it's not a part of the SQL Fundamental 1 exam objectives, and number two, Oracle has a separate certification track for Oracle development. But as you know, you're going to have your Oracle database on the back end, and then chances are you're going to have some front-end application. Now, frankly, we could bring this out into a multi-tier environment such that we have users interacting with a front-end tool. Most commonly now in the 21st century, this is a web application or a web browser hosted application. We could have a middle layer, a business logic tier, and then ultimately our back-end database. Potentially quite a few layers to go through. Now, views can be cool for consistency purposes because we want to make sure wherever possible to funnel users' queries through known channels. We want to avoid what's called ad hoc SQL. You might have heard of the security problem known as SQL injection. Tell you, so many sites, business, big e-commerce sites, fall victim to rudimentary problems because due to the way those front-end applications are written, malicious users can send arbitrary SQL code down into the database. We want to clean or sanitize all entry points to our database, and if we have views constructed and users through their front-end application run those views, then we have the exact same SQL statements coming down to the back-end database each time. That also has an advantage performance-wise because the SQL optimizer will find a query execution plan to satisfy the results of that view and then store that plan in memory. Now, it is true that users, in some cases, depending upon how your application is set up, can pass additional clauses along with the view. These are called predicates, also known as the where clause that we learned about earlier, and that can reduce performance a little bit because instead of plucking the stored execution plan from memory, Oracle will have to do what's called a hard parse, where it reads the view from scratch and processes it all together. All these having been said, views are a good thing and we need to learn how to use them. Now, the views that we're concentrating on in this course are standard views, what are called virtual tables, non-materialized views. We also have another kind of view that's beyond the scope of this course, but I want to discuss it just briefly for completeness, and that is the materialized view. Let me bring up a new whiteboard and I'll describe that in a little more detail. Whereas a standard view is just simply SQL code that's stored in the data dictionary, doesn't have any row data associated with it at all, and when we query the view, we're actually going to find the base table that does store the rows in data files. Materialized views look like views in as much as they are in fact stored queries, but check this out. The materialized view upon its running will actually gather those data rows and store them redundantly in your database. Now, yes, there's definitely storage implications here because if your materialized view pulls 10 gigabytes worth of data from base tables, then you're going to have 10 gigabytes in the view and of course the original 10 gigabytes in the source base table. Now, why would you want to do this? Well, number one, for performance. Number two, to reduce contention. In data warehousing environments, in ETL, extract, transform, load scenarios, when we're doing analytics, analytical processing, we can reduce contention, that is to say people hitting the base tables over and over and over again. We can offload that by essentially creating a subset copy of that data elsewhere and then freeing up locks and latches for additional users, you see. Another case where materialized views can be helpful is in a replication environment. Now, replication has as its root word replica, and replica of course means exact duplicate. So you may have different sites, physical, geographically distributed sites that need to query the same subset of data. Well, materialized views can be used in conjunction with Oracle replication technology to foster that. Now, is there a downside to material views besides the storage footprint? Well, we have to consider refresh. Think of it this way. We actually create the materialized view. At that time, the data is consistent between the base table and what's in the materialized view. But then, as time goes on, on, these rows are going to be stale, right? If we're doing modifications, if we're making updates, inserts, deletes on the base table, well, those changes aren't automatically going to be replicated to your view. That is, unless you have replication set up. So another point of planning that's crucial is that of data refresh. And again, it's beyond our scope to get into that to any greater detail, but what I will say is that we have a couple PLSQL built-in packages that contain methods that enable us to do a refresh. We have dbms_mview and also dbms_advisor that we can periodically call to make sure that our stored rows and our materialized view match what are in related base tables. Now then, let's have a look at view syntax. It's pretty straightforward actually. Because we've already mastered the select statement, we know all about how that works, and that's really half of the view syntax. The other half is just simple DDL. We can type create view or replace, which is useful in a development environment if we're recreating the definition of a view and we don't mind overwriting the definition that currently exists in the data dictionary. Actually, onReplace is crucial if we want to do a replace. Otherwise, if we just did create view and the same view name existed in the data dictionary, you would be denied by Oracle. After we name the view, we use the as connector keyword and then our select statement. It's as simple as that. So in this extraordinarily simple view called emp view, we're selecting 3 columns, first name, last name, and department ID from a single table. Now all the rules we looked at thus far with regard to where clauses, operators, expressions, joins are all valid here. The view, you have a blank canvas or a tabula rasa in terms of what you want your view to show. As I said, joins, aggregations, grouping, all that kind of stuff is all fair play. I'm probably sounding a little bit like a broken record here, but to rename views, we use rename. To make changes to the view, alter and drop. Now, we have to be concerned this time not only with rename, I've told you in the past that this may break things if you have dependencies, but alter also can cause problems. Here's the deal. When you create a view, as you know, in the view definition, you're referring to one or more base tables. And this stored query is what's stored in the data dictionary as such. Now, what if you or another database administrator makes a change to a base table? Something dramatic like a rename. Maybe the entire table's been renamed, or maybe an individual column within that table has been renamed. Well, what's going to happen the next time we run that view? Well, it's going to break the view. The view is going to be considered what's called invalid. In other words, the table and column references that are contained within the view syntax no longer match up to what's actually going on in your base table schema. The good news is we can perform an action called recompilation. It's alter view compile, and Oracle will seek out to resolve those discrepancies for you automatically. In my course for CBT Nuggets for the Oracle Certified Associate DBA1, we talk about and I do a demo on using recompilation. So if you have a Nugget streaming subscription, please make sure to check out those lessons at the very least. Final point on views before we get into our demo, in which I will show you both sequences and views. I want to talk about layered views and what's called predicate pushing. Now, what does this mean? First of all, the example you're seeing on screen comes to us courtesy of a really great site that I strongly recommend you check out, dba-oracle.com. And this shows us a couple different things. First, it shows us by SQL demonstration that we can layer views. And what I mean by that is you can create views that reference other views. Now, there's some controversy in terms of people who are really into Oracle performance on the upsides and downsides to doing it. On its face, it's okay when used simply and judiciously. View 1 here, that we're calling VW Layer 1, simply runs a select star from the employee table. Now check this out. View 2, that's called VW Layer 2 Department 100, selects everything from the first view and then adds a predicate. Again, a predicate is a synonym for a where clause. It's a way to restrict the number of rows that are returned by a query. So this is meant to demonstrate that we can layer views all day long. Now, if we run a query and add an additional predicate, like you see in this selection, select star from the layer 2 query where emp ID equals 100. Note that the filtering on view 2 is where department ID is 100. What actually happens? Well, this is where predicate pushing comes to the forefront. Oracle does this as a way to compress the query and increase its performance. The ultimate upshot, the way SQL is going to interpret this select statement, is that it's going to run basically what you see here. It will in effect run the top query, select star from emp, and push the second predicate, namely the one that we added to the view ourselves, into the second view's predicate. Actually, it's pushed two predicates in this case. It's pushed the view 2 predicate where deptno equals 100 and where emp id equals 100. It's pushed those up into the top level query. And the reason for this is for performance. Otherwise, Oracle would have to run one query, get those results, and then run the second query, and then finally get to your query. So predicate pushing, and I'm simplifying this somewhat. You'll want to check the Oracle documentation for the full skinny on this, but predicate pushing, is a built-in technology in Oracle Database 11g that Oracle uses to kind of compress your stacked views. And when you add predicates to those view runs, it combines them for greater runtime efficiency. In this demonstration, we'll have a look at using sequences and views in Oracle Database 11g. We're logged in as the HR user, and to start things off, I'm going to create two sample tables for our purposes called T6 and T7 respectively. The reason why I'm including these instead of just running them and having them ready at the start of this demo is that I want to build upon what we learned in the previous nugget, or couple of nuggets actually, in which we learned how to use the create table statement. You see that table 6 contains a primary key bound column, number 3 data type called ID. Second, col 1 is varchar 20, not null. Col 2 is a number 3. And then I've added constraints at the end of my column declarations. It looks like we have just one that I've named col 2 check that uses the check constraint type, and the evaluation or expression that Oracle uses for this column is that its value must be between 1 and 100. Okay, so that's table 6. T7, much more simple. We have an ID column and we have a second column called column 01. Guess I'll add an N here to make sure we're spelling it correctly. That's varchar 2 20, not null. Pretty easy. So let's select these in SQL Developer and run them. Alrighty then, we can verify by refreshing our connection list that those two tables have been created. Next, we'll jump right into sequences. I'm creating two sequences here just to give you a feel on how they work. Create sequence, sequent by 1, increment by 1, start with 1, min value 1. Simple as that. Second, create sequence, seek test sequence, increment by 100, start with 1000. You see, again, it's completely up to you and your business rules how you do these. This one I am specifying both a min value and a max value, and I want to cache the next 20. To rename, I'll rename test sequence to seek junk me, no problem, and then drop the sequence, drop. I hope you're looking down in the script output here. It gives us the success code of our actions. Next, I want to show you how to invoke the nextVal method when we're using a sequence. I'm running on lines 27 through 29 here 3 insert statements into our T6 table, and then of course we specify within parentheses a comma-separated list of the values for each column. Now, when we reference a sequence, you type the sequence name dot and then nextVal. Of course, this is case insensitive as SQL is. I have it all in uppercase just because. And then our second column was varchar, you'll remember, so we need to put that alphanumeric data in single quotes. Our third column in the table needs to be between 1 and 100, and all 3 values are, so we shouldn't have a problem here. All right, and we don't. And we can select splat from T6, and we see 21, 22, and 23. Now, what does that mean? That means I've been using this sequence already in other contexts, and it's not in fact resetting or reusing any numbers. So Oracle must have determined the next 3 values in that sequence that were available were 21, 22, and 23. That is just, again, a gotcha that if you have a need for an uninterrupted sequence, in other words, with no gaps, then you're going to have to use some other method. Sequences are limited in that result, unfortunately. So it stands to reason that if we insert a row into our table 7, our T7, again specifying the sequence name dot nextVal, and then some alphanumeric data, and then we select splat from T7. Again, ID is 24. I think I've shown you how that works pretty well. On the graphical side of things in SQL Developer, and this can be helpful for us as we learn SQL, as you know, because you can always see the DDL. Sequences node, if we expand it, shows us any sequences that we've created. Give it a double click and it will show you that DDL right here. No muss, no fuss, no greasy aftertaste. Create a sequence in the graphical. We can right-click sequences and select new sequence, and this gives us same thing really. I'm just going to call this test_seq, specify the properties, increment by 1, start with 1, min value 1, I'll leave max value alone. If you're going to cache, what the cache size is going to be, and then if we go to DDL, it shows us exactly what's going on behind the scenes. Show you another example. Let me create a sequence called seq by 1. Starts with 1, no upper limit, no caching. Also create seq by 100 that starts with 100 and increments by 100. Way to test these just in a development environment. Remember our friend the dual table? We can run next val against dual, and it tells us here 1 is what we start with. Let's run it again. Gives us 2, 3, etc. ad nauseum. But again, remember, once you've burned the number, it's going to start at 5 the next time I invoke next val, unless, of course, we change our sequence to alter sequence, and we can again reset the start with value if we want to. And then I'm not actually going to run this SQL, but let's take a look at lines 15 through 23. Same old stuff really. Creating a table called t-test, 2 columns, and then we're inserting into that table next val, next val. Think you've got it. Sequences, that's pretty much all there is to it. Let's seamlessly transition now into a consideration of views. To set the stage on lines 26 and 27, we can select all columns from employees in order by department ID. Now there's a lot that comes back and there's a lot of columns. Thing you want to be careful of, sometimes DBAs are a little bit crazy with their views. They select too much. And you're selecting not only vertically but horizontally. Horizontal selection refers to the number of columns that you're selecting, and you want to be reasonable in that number. Don't be nuts. So we can cut down on those rows and be judicious to create a view like empty 50 as select employee ID, first name, last name, hire date from employees where department ID equals 50. So this is giving us a much more reasonable number of views. Now if we describe the view, it gives us the columns, the nullability, and type of those columns, but what about the text of the view itself? How do we get that? Well, you can easily get it here through the graphical user interface, but for the purposes of the exam, we can't rely on this. So let's turn to the data dictionary to answer that question. As it happens, you can query the user_views data dictionary view, and I know we haven't discussed the data dictionary formally yet. We will later in the course, but essentially, user_views gives you insight into the metadata concerning all the views that you own or that you've created. Text is a column within user views that shows the view definition. So this where statement tells us we want to look at only our empd50 view. Now you'll note I didn't get anything back. I mentioned to you that in the data dictionary, table names are listed in uppercase. So let me change that to uppercase, run it again, and of course now we get the full text back that shows us exactly what's going on here. Now I'm going to actually alter this view, and I'm going to add with check option to its definition. Now alter view isn't going to work in this case, so I'm redefining the view with create or replace view, and I've added with check option. This is not an Oracle specific option. You'll see it in any RDBMS view syntax worth its salt. Here's the deal with it. It is a constraint that we add to views that ensures that if we're allowing DML to this view, that is to say, instead of just reading rows, if we're giving particular users the ability to say update rows in the view results, that the users cannot make any changes to the view contents that would force a row to not be included in this query. So in this particular view, it shows us employee IDs, first name, last name, and hire date from department 50 only. So let me run a select splat from empty 50 and just have a look at the actual raw data. So we could give a data entry operator the ability to make changes here to any of these fields. Let's say an employee gets married and her last name, instead of Shanta Valman, it's Shanta Warner, let's say. We can make that happen, but we won't be able to make any changes that would result in a user falling out of the scope of the view. So in other words, they could only modify those in department ID. I mean, we could very easily, just for grins, add department ID as a column in the definition. So now if we run the query, of course it's no surprise because the where clause rounds up folks only from department ID 50, but it's feasible that we could run update against this view. And in fact, why don't we try that right now? So I'm using update here, and again, we're going to learn how to use update formally later in the course, so take it on faith as we're walking through it now. We're updating the empty 50 view, and we're setting the last name to Warner where the last name equals Valman. Now that's not going to change or cause this person to fall outside the scope of the view. So sure enough, one row updated, and if we select Splat, we now see Shanta Warner. Now let's reformulate this update statement. Now, update empty 50, set department ID to 40 where the last name equals Warner. Let's take a look at this guy and see what happens. Sure enough, we get an SQL error of 1402 or a error, view with check option where clause violation, and it's not letting it happen. You see? So again, with check option is crucial that you understand. It's a great way to put constraints on the view. Line 60 shows us a view called salary analysis that runs quite a bit actually. We're selecting columns from more than one table, actually employees and departments. We're doing that through a traditional equijoin or inner join. We're also rounding up, grouping, and running aggregations on the salary column, showing us min and max salary, and we're grouping by department ID and department name. That's a pretty honkin' large view, and if we select against the view, it's a nice way to round up department names, the department IDs, and then the min and max salaries per department. Pretty nice. Creating other schema objects, part 1 of 2 review. We started this nugget by looking at sequences. We now know what these are and how they can be used, as well as, of course, why they'd be used in Oracle Database 11G. Good technology that has a couple gotchas with which you're fully apprised. We spent the majority of our nugget discussing views. You now at this point should understand the difference between a base table and a view. You should understand normal views or traditional views versus materialized views, and you should also understand how to use views in a DDL context. I hope that this has been informative for you, and I'd like to thank you for viewing.